G'day. Part one of the Waldown video, we're making up these pulleys here, and probably putting the grooves in was the hardest part of this, or the most difficult part of this. They're basically just a cylindrical piece of aluminium, step down, bore in the middle, key, not a big deal. Today's video is for the intermediate pulley, which is actually a two-piece arrangement. That goes in there, there's a couple of bearings fitted, all that sort of thing. It all has to be concentric, and so this is a little bit more complicated. And so today's video is basically this. I had hoped to wrap things up by now, but it looks like we'll be going into a third video for the fitting and all that sort of thing, and possibly even a fourth if I have to modify guards in a major way. This is the intermediate pulley. I've trimmed it up on the lathe, and now I'm putting a square pocket in the top, and what I'm going to use that for is there are a couple of sheaves that have to go in here, but one of them is going to be too small for the existing bearing to sit in. So what I'm going to do is actually have two pieces here and use and have the bearing in the top of the small piece, but use this as a key. Now some people have said, oh, for the amount of power this thing transmits, that's overkill. Yes, it is, but because I've got a bearing located in this section, I have a bearing in the bottom here. I want to make sure that this is a pretty tight location. So this square cavity is not so much for power transmission as for location and fit. Here's the finished pocketing, I guess you'd call it. I'm 0.05 of a millimetre undersized that way, but spot on that way, so that's all good. I'm now going to square up a block that will fit in there. I guess two things. One is the squared block will actually have a radius on the corner, so it'll fit in here. There are techniques you can use if you need to have a square-sided piece or a square-cornered piece mating, but I don't need that in this case. I guess another question would be, well, why couldn't you mount this thing with a key? And the reason for that is I'm trying to keep the balance as good as I can. And if I have a key, it means I've got a lump of steel sitting out at a radius, and that'll potentially throw the balance out. I've just finished squaring up my stock here and then locating it. When doing this, just as a tip, if you haven't already worked this one out, just rock your material back a little bit back and forth a little bit like that until you get the indicator needle sort of reaching its limits of the travel, and that'll tell you you're actually square to the face, lowest point, and all that sort of thing. Anyway, so I now need to put some relief on the corners here, so it'll fit into my into the socket on my intermediate pulley. I'll then turn that around and then rough out the blanks for the two sheaves that are going to sit on here. So I've got my corners relieved. I'm now using my parting tool as a grooving tool and putting a groove in, basically to make that pretty much round, as far as up as I can go, because what I want to do is reverse that in the lathe. Hold on the corners, because they're the bits that if I put a bit of a mark on them, I'm not going to mind so much. It's just for corner relief. And then I can finish cleaning this up and rough out the sheave diameters. Here's the partway done product. So that fits in there just nicely. I might need to give a lick of emery on the edges there just to get that to settle in. I've got a large radius there which will fit inside the small radius there, so that's all good. I now need to put this back into the lathe chuck. I'll hang on to the corners here, clean this up, take it down to the approximate size, and then I'm away to go. I still need to put a hole through the middle, put a recess in there for a bearing. For those who watched my order of operations video, this wasn't a terribly nice cut to do. It would have been far nicer to be able to turn that down, have that to size and then flatten that off, but I figured it was probably easier to square this up in the mill rather than try to hold a bit of round to square it up exactly to size, because I want that to be concentric basically with the corners there. Here's my blank, much swarf later, as you can see. I've taken that down to close to my final size. I want to mount it up on the intermediate pulley first and just check what the run out is. I want everything to be as concentric as I can, so I'll mount that up. If necessary, bore the end there. All the other things that have to be done. A couple of things about this one. If you ever have a square object and you need to put holes on corners, you can actually use the centering function on a combination square, and so that just goes there, and that'll actually give you a diagonal line across that thing. Something you forget about, and every so often you discover again and think, yeah, that's a good idea. These holes I spotted through with a tapping drill size into the main pulley, and then opened them up. Nothing too exciting there. I've got a couple of little bumps there just to make sure I get my alignment right. I don't like using countersunk screws that often, because what will happen is that countersink, unless it's spot on the axis of the hole, can tend to pull the screw over and bind. So my preference for this would have been something like a pan head or a socket head. Can't fit those because that's a pulley and I just haven't got the thickness there, and I didn't want to make the thickness, and so I'm using a countersink, but they're not my preferred style of screw for this sort of thing. Here's where my cunning plan starts to take shape. The intermediate pulley is supported on a shaft with a bearing top and bottom. It just runs on that shaft. The bottom bearing I'm just going to counterbore straight into there. The top bearing, because you want your bearings separated as much as you can, I'm going to put into here, to the back of this, and that'll just gain me an extra, that much, which is not to be sneezed at. This piece of material here, just to confess, I've had about 3 or 4 iterations of this plan, and I actually cut this material to the wrong iteration. So this is another piece of aluminium. I've counterbored it in there, I've used Loctite on there, and what I'll eventually do when I get this machine down to size is I'll probably put a Scotch key in there just to keep that in place, but that shouldn't be a problem. Around here I've got some measurements. I got a depth mic in, and I just checked the depth here versus the depth of the flange. I'm good. I've over counterbored these holes a little bit, but that's so that if I need to, when I've got this all bolted up and on a mandrel, I can come along and just take a bit of a skim off the top here without having to worry about hitting a screw. This is my blank, all roughed down to size. The top part screwed on. I've got a bore in there. I haven't counterbored that for the bearing yet. That's going to wait, because I want more support in there. What I'm now going to do is use an expanding mandrel. So these come in a variety of sizes. You push the tapered part in, and that springs open the collet part here. I'm going to put that in there like so, and that will give me a mandrel to turn that on. Okay. Now, some of you may not have expanding mandrels. Some of you may be saying, well, that won't work for my drill press. Plan B, and it's always worthwhile to have a plan B when you're doing something even the slightest bit tricky, was to make up a threaded mandrel with a stop on here. That would locate in that bearing housing there. That being the split there. So that would locate in there. I've got a piece 16 diameter with a centre in it that I can put in the centre of the tailstock or the headstock, and I've got a screwed here, screwed on nut here with another centre in, so I can locate there. I can put my lathe dogs either end and go from there. So that was plan B. Fortunately, we don't need it, but, well, we don't need it at the moment. This is the setup I'm using. I was going to use a different dog to hold this because these dogs that I just made up recently were a little bit on the too short side, but as you can see I've managed to instead to make up an extension piece which just pushes that into the slot on my my drive. I've taken these down to width, and I get to take them across, put the grooves in and all the rest of it. The reason I wanted to do this on a mandrel was that I could then turn this 180 degrees and I'd get the axis still in the same spot, so all these belts would be concentric to each other rather than having a slight shimmy or something like that in there, which I was trying to avoid. This bit here is it's just blank for boring the bore and doing a bit of height adjustment, and in hindsight I wish I'd left a little bit of extra material here because you can possibly see that the screw is only just making contact with the top there. These two haven't been taken down to size yet. These three haven't been taken down to size yet, and that's because I was anticipating wanting to use that surface to drive from, so I'm going to machine these 4 sheaves and then reverse this, put a dog on the mandrel, and then finish off these 3. Here we are at the halfway mark. I've done my 4 grooves on this side. I now need to turn it over and do the 3 on here. My dodgy lathe dog setup seems to have held, so fingers crossed I can swap it around and I've suffered no ill effects. Just to briefly explain how I'm doing this, I've previously come along and made those all the same width, which is 10.8 is my target number. I'm now coming along and measuring that. I purposely left some excess material on the diameters. I'm now coming along and taking that off. I've got my depth stop set up so that it'll tell me when I get up to this surface. Because these are now all standard 10.8, I can use the compound slide to index my grooving tool along using that face as an offset. So this one's okay, this one's okay, this one I'm hoping will clean up, and I'm going to have to take a little bit of material off that too because it's purposely left long. It should have been longer, but that's okay. The parting blade will get in there and take that off. So another step in the process. I hope that's been useful to people, and thanks to those who've inspired me with my metalworking.